So we can't hear you, Carrie.
Can you hear me now at all?
No, yes, it's better.
That is better?
Certainly no, yes.
Huh. Yeah, well, we'll try it like this. We can try to go ahead and get started. And
all right.
Okay, so we have total 26 questions to go through. And then it says for section 3 of the reading, it says questions 1 through 6, understand confidence intervals. It says given a 90% confidence interval of 45 and 105 for Nenhart rate, which of the following is the best interpretation of this confidence interval?
So I put A on that one.
Yes, the true mean in between that margin.
Yes, that's what I put there.
Thank you. Then it is given us some information, and then it says in number 2, the researchers decided to construct a confidence interval to determine how the difference of the means is significant. To determine whether the confidence interval would be reliable, they create QQ plots of both random samples and say that they are approximately normal. Are the requirements for constructing the confidence interval satisfied? Why or why not? We have randomly selected 20 females and 15 males to participate. This one, with this one I selected B, but I'm not sure on this one.
That is what I selected also.
Total of 35, but I don't know if you're taking those together, because if not, if we're taking those separately, it's not that big.
Right, but it says where it created the QQ plots.
Mm-hmm.
And it showed that they're approximately normal.
Mm-hmm. That's what I picked. What about you, Sean?
Yes, the distribution of the means is normal since the data have been determined to be normal.
Correct.
That's what I had, yeah.
So B, only because they said that it appeared to be approximately normal.
Yes.
Okay.
Okay, so who wants to read number 3?
I'll go. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? And that one I put as D, but I wasn't positive on this one.
I selected C.
I thought it was between B or D with a stronger preference towards D.
Yeah, I don't think it was C because the two subjects they don't depend on each other,
Right.
so I don't think C. They're not a dependent sample.
They're independent, correct?
Right. So I think I was kind of with you with between B and D, but I was leaning towards D and chose that one.
Did you say B as in boy or D as in dog?
D as in dog.
That's what I leaned heavier towards, was D as in dog.
Okay. Thank you for clarifying it.
Because it doesn't really give you what the sigma was.
That's right.
The standard deviation, right?
Correct.
So I'm going to go with D. It was okay.
Okay, now for number 4, says a researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be 3402.08 and 4142.75. Which one would produce a confidence interval with a smaller margin of error than this 95 confidence interval? Selected letter B, obtaining the balances of 90 bank customers rather than 30.
That's what I selected as well. It gives you a greater data range, correct?
Right.
Yes, if you increase the data, it reduces the margin of error.
Yep. That's what I got.
Okay, so who wants to read number 5?
I'll read it. A factory makes propeller drive shafts for ships. A quality assurance engineer at the factory needs to estimate the true mean length of the shafts. Randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 100 millimeters or 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of the shafts. So I did the X bar plus or minus. The confidence interval critical value is 1.96 plus or minus standard deviation divided by square root of n to come up with 998.040 on the low end and 1001.960 on the high, which was A.
A. That is what I got also.
Yes. Select A.
Okay. I'll read 6. To assess the accuracy of laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weighings is computed. Suppose the scale readings are normally distributed with unknown mean mu and standard deviation 0.01 grams. How large should n be so that a 95% confidence interval for mu has a margin of error of plus or minus 0.0001? And on this one, I got C, 38416.
Yes, 38416.
That's what I got as well.
So that's fine. Okay, so question 7, it says question 7 through 14, understanding hypothesis testing. The mean RMU of the several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypotheses for mu are, and I selected option A, mu equal to 1250, and the alternative less than 1250.
Yep, that's what I got.
You said A, is that correct? Did I hear you?
Yes.
That's what I got as well. For a while, I struggled with that one, trying to figure out. My brain didn't want to remember which one was less than or greater than for some strange reason. Okay, so that puts us on to number 8 in a statistical test of hypothesis. We say the test result is statistically significant at the level of significance alpha if the p-value is less than the level of significance, which was B.
That is what I got also.
Yes. It's true as well.
All right, number 9. A group of statistics students wants to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of size 15 from each of the 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample standard deviations are nearly equal. Can they use an ANOVA hypothesis test to answer their question? This one I wasn't sure, but I did see that we don't have enough data.
Yes, it was with C and D because as well we don't have the deviations to verify that requirement.
Right. That's what I put. I didn't think that they had enough data. Was it the variance? Is that what we were missing correctly?
Right, that's what I was thinking.
Yes.
Because that's the one where you had to make sure that one of them wasn't 4 times greater than
4 times and smaller, yes.
Right.
Okay.
We got for 10, it says a medical researcher is working in a new treatment for a certain type of cancer. The average survival time after the diagnosis for the standard treatment is 2 years. So the null hypothesis that average survival time after diagnosis is the same for the new treatment and the standard treatment. An early trial, she tries the new treatment on 3 subjects. You have an average survival time after diagnosis of 4.5 years, even though the sample is small. The null hypothesis would be rejected at the 0.05 significance level. Consequently, she rejects the null hypothesis in a future study. It is determined that the new treatment does not increase the mean survival time and the population of all patients with this particular type of cancer. The researcher has, I selected, committed a type 1 error.
That's what I put
right?
as well.
Yep.
Yes, because the null was rejected.
Right. When it shouldn't have been. Okay, number 11, it says if the level of significance is made very small, thereby making the probability to commit a type 1 error very small, what happens to the probability of committing a type 2 error? And I put D as in David, because by reducing the probability of committing a type 1 error, we increase the probability of committing a type 2 error.
That's what I got. All right, number 12. The nicotine content in cigarettes of a certain brand is normally distributed with mean in milligrams mu and a known standard deviation of 0.17. Brand advertises that the mean nicotine content of its cigarettes is 1.5. Measurements on a random sample of 100 cigarettes of this brand give a sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis equals 1.5 or greater than 1.5 at the 5% level of significance. You conclude that you should, and I put D, reject the null hypothesis.
Yes. I rejected the null as well. Getting 0.039 as the p-value.
What was your p-value again?
I got 0.039.
I came up with 0.0776. How did I mess that up?
Well, the formula I use, I don't know if I am completely right, but the one I selected, it's the one for the C-score. Having 1.53 minus 1.5 divided by 0.17 divided by the square root of 100.
And what'd you get for a Z value?
1.765.
Okay, that's what I got. And then when you put that into your probability applet,
You
Yeah,
got to
it's-
make sure you just have the right side shaded too on that.
just the
because-
right side, is that correct?
Yes, just the right side because it's asking us for greater than.
That's where I messed up. Okay. Had them both once again. So right side only because it's greater. Higher. 0.0388 or 39. So then you would reject the null. Is that correct? Because its
Correct. Yes.
value is now less than alpha.
Right.
Okay. Right side shaded.
Okay. So for number 13. So it's your turn. It's my turn to read.
I just read the last one.
Okay, so then I'll read 13. It says, you would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? That's when I selected independent sample tests.
Which is D as in dog, right?
That's
Yes.
what I put. D as in
Yep.
dog, independent sample tests.
Perfect.
Okay, so 14. An educator is interested in an academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sisters pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent or dependent sampling? And I chose D as in dog as well for if you select a brother, you include that sister.
That is what I got.
Mhm. Yes, because either or they will be affected as well.
Okay.
All right, so 15, a soil scientist collected random soil samples from a field and measured the dissolved organic carbon level of each sample. Dissolved organic carbon molecules are an important part of an ecosystem and help plants to process organic compounds. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. Open that data file and use the information to answer questions 15 and 16. 15, one of the four types of confidence intervals listed below. Which one is the appropriate for this situation? I put B, confidence interval when the standard deviation is unknown.
Yes, that's why I selected.
B is in boy, correct? One unknown.
Correct.
Then it says, which of the following is the 95% confidence interval for this data? And I selected D as David, 11.168 and 15.217.
That's what I got.
I'm sorry, what was that again?
Letter D, 11.168 and 15.217.
Now, which spreadsheet did you use to calculate that? Just to make sure that I got it right. Because like I said, I was having issues opening them up today and trying to make sure I got the right one. Was that confidence quantitative interval procedures?
Yes, I don't quite remember, but yes, that's the one that I used because I was just entering the information.
Right.
Mm-hmm. So then
One
it was
sample t-test.
mm-hmm. Yes, that one. Just enter the information in there. Because we have just one last, and then I just changed it to the confidence level of 0.95, and then it gave me the 11.65, and yes, one sample t-test for means.
Okay. Try this again here, because like I said, I've just I can't even control. Okay, so finally, it goes ahead and works for me here. This is where I started running into problems because I can't see whenever I try to paste things or copy things. It's my screen ghosts everything out. So I'm having a heck of a time.
Wow.
What happens when you drop your computer, I guess. Way to go.
That's annoying.
Okay. So it says the next question for internet. A random sample of Hummers for sale in Los Angeles and New York were taken from listing at cars.com. We want to know if there's a difference in the mean listings. Price between Hummers and sales in Los Angeles Group 1 and Hummers for sale in New York Group 2. Create a 95% confidence interval and a true difference of mean listing prices between two cities. Open up the data file used Hummers. Plug my computer in. I'm hoping that when I restart my computer, which would have taken who knows however long, that it will rectify whatever I have done. So anyway, of the 4 types of confidence intervals listed below, which one is the appropriate for this situation? So I didn't calculate this one, but
I selected D.
D is it because they're not dependent.
Mhm.
Right.
The confidence intervals for those that are not.
Yes.
I chose D as in dog also.
Mhm. Fine.
Open that up.
So then on 18, which of the following is the 95% confidence interval for the true difference of mean listing price between Hummers from LA and New York? I put C, the negative 423 and 5417.
Yes. That's came up.
So with this ghosting, just so that I make sure that I'm doing this correctly without being able to see it, I would take the prices and I would enter them into the 2 sample to get the numbers, correct?
Yes.
All right.
Now going with the next.
And what
Go ahead.
was your number there that you said again, Kerry?
It was the C, so it's negative 423 and 5,417.
Okay.
Connection says many studies have suggested that there is a link between exercise and healthy bones. Exercise stresses the bones and this causes them to get stronger. One study examined the effect of jumping on the bone density of growing rats. There were 3 groups. Rats were selected at random for 3 groups. A control with no jumping, a low jump group. The jump height was 30 centimeters, and a high jump group 60 centimeters at 3 weeks of 10 jumps per day, 5 days per week. The bone density of the rats expressed in analysis was measured. The rats were selected at random for the 3 groups. Researchers would like to perform a hypothesis test to determine if the mean levels of bones density are different between the 3 different groups of rats listed above. Is there a level of significance of alpha equal 0.05? Up in the data file uses information to answer questions. What is the correct hypothesis test for this situation? And I chose letter E, an analysis of variance.
Yep, that's what I got.
Yes. Yep.
Mm-hmm.
Oh, okay. I can't, like I said, I can open the data, but I can't, whenever I go to copy and paste it, I get a white screen. So I did not get these calculated.
I got for this one F equal to 7.978.
23. Yep, that's what I got also, C.
I'm sorry, what was that?
Letter C.
Yeah, letter C, 7.978.
Okay, I'll have to see if I can calculate that again.
And then for 21, the p-value, I got B, 0.002.
Yes.
Okay.
Then for 22 it says, which of the following best expresses the conclusion of this test? You see level of significance of alpha equal 0.05. This one I selected B, because there is sufficient evidence to conclude that the bone density of at least one of the groups is different from the bone density of at least one of the other groups.
Yeah, this one I was debating between B and C, whether there was insufficient evidence that they were all the same, or if there was sufficient evidence.
Right.
Yes, I was going with B because it says at least one of those is different from each other.
Mm-hmm.
Right.
Yeah, so I think B sounds good.
Hmm.
Okay, so B it is. Pressure of supply and demand act directly on the prices of an airline ticket. As the seats available on the plane begin to fill, airline raises the price. If the seats on a flight do not sell well, an airline may discount the tickets or even cancel the flight. A study was undertaken to determine if there's a difference in the mean cost of an airline ticket purchased 90 days in advance of a scheduled flight compared with a ticket purchased only 14 days in advance. Data was collected on the cost of a one-way ticket from London Heathrow to a variety of destinations in Europe. The lowest published ticket of one-way flights from Heathrow to various destinations in Europe was recorded for each scheduled flight 90 days in advance and then again 14 days in advance. Perform a hypothesis test to determine if there is a difference in the cost of a non-stop flight when a ticket is purchased 14 days in advance compared to 90 days in advance. Use the level of significance, alpha equals 0.10. Open the data file direct flight cost. Use this information to answer 23 through 26. What is the correct hypothesis test for this situation? So that was going to be direct. That's dependent because if you choose one area to one flight to another, you're using a matched pair set, and it's a before and after. So
Correct.
Yep.
Yeah, so it was selected as well. That one, C.
Right.
Okay. Then it says to calculate the test statistic. I put A, but I'm trying to think if I change it to a 0.10 for the level of significance.
So whenever I just placed the information in here, Curry, were you getting the test statistic? It was giving me just not finding the values. I don't know if something was wrong with the spreadsheet, but it was not giving me the value.
Yeah, I'm trying to. Let me double check this one.
Let me do it again.
We did this one together not very long ago. I don't remember what it was that we.
Yes, I remember this one as well, but not completely sure of what it was. Just copy and paste it. I think I got it, and Because this will be the 90 days first and then the 14 on the second column, right?
Yes.
Let's place, where's the 90 days? And then the 40 days. Yes, I don't know why that one was not working, but now it's working. And it's given me the T-score for 1.685.
Did you change your confidence level?
It says to 95, right?
Is it 9? Is it supposed to be a 9.5?
No, no, it says 90, 90. Didn't change it. Let me change it.
Yeah, I think that's what I did when I first did it.
See what happens if I can get this one. If I might be able to actually contribute to this part of it. Maybe.
Let's change it to 90%, but still it's giving me 1.685.
When I changed my confidence level to 0.9, it gave me a T-score of 1.636. Oh, you know what though? I forgot. There's a couple of them that you have to delete out of it.
Mm-hmm.
I did not do that.
Yes, there are some blank spaces on there. Yeah, so we have a total of 88 per group.
Okay, so yeah, now I do get 1.685.
Mm-hmm. Then the p-value is coming at 0.096, which is letter B.
So when you don't have one that shows up, like you had the one where you had a 90 day but not a 14, and then another one you had a 14 but not a, or I mean, yeah, you had the opposite. Do you take those completely out of the equation?
Yeah, that's what I did. Just deleted the whole line there.
Okay. All right. So I'm trying to, like I said, I'm trying to. All right.
Mm-hmm. So then for 26, it's asking us which of the following best expresses the conclusion of this test. Since the p-value is 0.09. So
I'm sorry.
Go ahead.
So you're using a 0.9 confidence level.
Correct.
And we're trying to find out. If they're not equal. Is that correct?
Yes.
Right.
Yes. Mm-hmm.
And what did you have for p-value again, Kerry?
The 0.096.
I'm coming up with a 0.7, and I'm not sure why.
For this one, I just used the spreadsheet to get the information.
Right. Okay.
You're using the paired sample t-test spreadsheet?
Yep. Let me try it again here. .948. I'm still getting. Let me try this again. Maybe that's not equal to. I've got to have something messed up here with it ghosting because it's just not can't be pasting the data correctly. Because I end up with a t-score of negative 1.654, and then a p-value of 0.102.
It seems like some decimals are missed there.
Something's not right. Okay, well let's carry on here. I'll figure it out.
Okay, so the p-value is less than the level of significance, so we reject the null. So we can conclude that it will be that there is no difference, right, in the cost tickets purchased for 2 days because we rejected the null.
Right. So D as in dog.
Oh, I was thinking of A or B because we rejected the null because the level of significance is 0.10 and our p-value is 0.096.
You're right.
I would say it will be letter A because they are trying to check if there is any difference, but if we rejected a null, it means like there is no difference, right?
So, yeah. So H naught on, so your null hypothesis on this one, just so that I understand it correctly, is going to be that U1 is equal to U2, correct?
Right.
Hmm?
And the null hypothesis, or I mean the alternate,
Not equal.
is just that they're not equal. So you're with the level of significance at 0.1, the p-value is 0.096,
Yes.
and therefore p is less than alpha, so you reject the null, which says there is sufficient evidence to conclude that there is a difference in the cost of tickets purchased 14 days in advance.
So letter B as in boy.
B is in boy.
Yes, I was thinking A or B. Yes, it makes sense.
That's the way that I read that. And I apologize for dragging you guys through this slower tonight.
No worries. That happens.
I mean, every time that I go right click or use the keyboard commands to copy and paste something, everything that I try to highlight, it just ghosts to where I have an outline of a box and all the cells go blank. So,
Oh.
Wow. Not lucky. Okay, but if you want, then we can move on to the quiz to submit the answers.
all right, let's do it.
Here. Okay, so for question 2. God, A. Choose D.
Are these all in the same order? Like,
No,
is
I
A
don't
going to
think
be?
they're the same order. I think the questions are the same, but the answers are in different order.
Yeah, correct.
Well, that's going to be tricky because I just have the letters written down.
Me too. Is the following information: the University of Mississippi.
So I printed it out and circled mine. So for whatever that's worth. So given a 90% on number 2, given a 90% confident interval of 45 and comma 105 for main heart rate, which of the following is the best interpretation of the confidence interval? We are 90% confident that the true mean of the heart rate is between 45 and 105. So in this particular case, that's the second choice. So question 2, using the information we've already covered, researchers at Mississippi wanted to determine reaction time for go, no go. Researchers decided, question 3 says they decided to construct a confidence interval to determine if the difference of the means is significant. Determine whether confidence interval would be reliable. They created a QQ plot in both random samples. So they're approximately normal. Are the requirements for constructing confidence intervals satisfied? Why or why not? We said yes, the distribution of the mean of each sample is normal since the data have been determined to be normal, which is C, or the third choice. Of the 4 types of confidence intervals, below which is the appropriate for the experiment, we chose confidence interval for a difference of means using independent samples. Question 5, which was the researcher interested in estimating savings accounts, random sample of 30 customers, 95% confidence interval, mean savings found 32,408 or 3402.08 and 4142.75. Which of the following would produce confidence interval with a smaller margin of error than 95% confidence interval? Obtaining a balance of 90 rather than 30, and that's because Kevin said that if you increase, you reduce the margin. Factory makes propellers. Randomly select 4. Mean of 1,000 millimeters. Standard deviation of 2. True mean lengths of a shaft. Input your answer for the margin of error, lower bounds and upper bounds. Margin of error for the 90% confidence interval. Did we do the margin of error on this one?
It's 1.961.
1.961.
Yes.
Okay.
Yes, because we have, just to make sure, we have 1,001.960 minus 998.040. We got 3.92 divided by 6. But
Did you freeze up, Kevin, or did I just lose you? There you are.
now I just was writing down 1.961, but from the mathematics I'm doing, I'm getting 1.96.
Right.
Because it doesn't specify if it needs 3 decimal places or just 2.
So are you just putting 1.96 then?
Yes.
Okay. So that's the critical value, correct? The margin of error?
Yes.
Okay.
1.96. And it says the lower bound.
So when we calculated margin of error earlier for a 95% confidence interval in another assignment, the margin of error was the z-score divided by the standard deviation.
Right.
Z-score times standard deviation divided by the square root of n.
Correct.
So if that's the case, let's do a little math here real quick. Margin equals z times standard deviation by square root of n. Particular.
That's right. Yeah, because the standard deviation is 2, and then the square root of the 4 things is 2, so that just equals the 1, which makes it 1 times the 1.96.
Right. Okay. So it's 1.96. Good job. Just want to make sure.
Oh, yeah, I was wondering about that too, but.
Mhm.
Okay. So lower bound was 998.040.
Yes.
040?
Correct. 040.
The upper bound was 1001.960.
Yes. Correct.
Okay. So now we're at the laboratory scale one. How large should your population be so that you have a 95% confidence interval and a mean of a margin error of 0 plus or minus 0.001? So this was that n formula equals z times standard deviation divided by margin of error. So calculating 1.96 times 0.01 divided by 0.001, we came up with an answer of 38416.
Correct.
Okay, so questions. The next questions were understanding hypothesis testing. Anybody? So we chose the apartment smaller. The hypothesis, the null hypothesis was U equaled 1250. And the alternative U was less than 1250.
Right.
Correct.
That's the bottom one. 11, which was actually 8. P-value is less than alpha.
Yeah.
Mhm.
Group of statistics students determine this apartment building gets better grades than students in another. Collect 4 GPAs from 4 random in the size of 15. Can they use an ANOVA hypothesis test? And we said no, that they did not have enough data.
Correct.
That's right.
We said they committed a type 1 error.
Right.
Yes.
Okay. If level of significance is very small, making probability very small, what happens? Probability type 2. Reducing probability committing a type 1. We increase probability because they're inversely related, correct?
Yes.
Right, that's that first one.
Okay.
Increase probability.
Nicotine content. After it was all over and done with, we said that we reject the null.
Mm-hmm.
So mean number of hours worked, wages per week, 100. What is the correct statistical? We said independent sample test. And then for brothers and sisters, it was dependent. If you select a brother, you get the sister.
Correct.
Soil selection, confidence interval for you, segment unknown. Unknown. That's the first one. Standard deviation is unknown. Okay, which of the following is a 95% confidence interval for this analysis? Put your answer for the margin of error, lower bound and upper bound. So
For the margin of error, I'm getting 2.025. Is that what you're getting?
2.025.
2.025.
okay. Then we've got lower bound. $11.168.
Yes.
11.168.
15.217. Okay. Where are we at here? Let me keep going. So it gives us a random sample of Hummers. Where did that go? There it is. Confidence interval for the difference of means using independent samples. Which of the following is a 95% confidence interval for the true difference of mean listing prices between Hummers in LA and New York? Lower bound was -423.
Says to round to 3 decimal points, which in the answers we had that didn't have decimals.
Okay.
No, I'm just living it as an entire number.
So I don't know if I need to plug that
And then the upper. Yes.
On the spreadsheet, was there decimal places or not?
I think there was. I'm trying to pull it up now and put it in again.
This is for independent symbols.
This is a 95 confidence level, right?
Yes.
Yeah. Lower bound, I get -423.238.
238.
And then the upper bound was 5417.336.
Thank you.
Can you repeat that, Carrie, please?
Yeah, that last one.
Yeah, both of
I
them.
was- The lower bound is negative 423.238.
Okay.
And then the upper bound is 5417.336.
336. 5417.336.
Right.
Okay. Thank you. All right. So question 25 on here is, what is the correct hypothesis for situation when we're dealing with the bone density? And we chose ANOVA.
Yeah.
Calculate the test statistic. Did you write that down, Kevin?
Yes. 7.978.
7.978.
Okay.
P-value is 0.002.
Okay. And then which expresses the best conclusion of the test? Is that correct? Use a level of significance of 0.05. There is sufficient evidence to conclude that the bone density of at least one of the groups is different from the mean bone density of the other. So that's B, the second one there.
I have it as my fourth
No.
one.
Sufficient. There is sufficient.
There
Yeah.
is yes, it's the third option.
Mine's the fourth one. I don't know if it's
Fourth one down. 1, 2, 3, 4. There is not. There is. Yep. Okay.
Mhm.
Read correctly. All right. So now we're on to airfare. We chose dependent sample tests because they're dependent upon one another.
Mhm.
Matched pairs. You guys calculated it because I can't see it. And
30 is the test statistic for that. It's 1.685.
1.685.
P-value 0.096.
96. And which of the following expression concludes the test? There is sufficient evidence to conclude that there is a difference in cost. There is sufficient evidence that there is.
The difference of cost of goods purchased.
So I have that as my second one.
Second one, right?
Yes.
All right. Go to submit quiz. Submit quiz. Mine says 28 out of 30. So
I missed number 1, 12, and yes, 1 and 12.
you did not actively participate?
It was unanswered question 2.
Okay.
So I just showed 12 being wrong.
Let me go down here.
So what did you select for question 2?
For question 2?
Yeah, so just missed that one, just not selecting the right one.
Given 90% confidence
second.
interval.
Yes, it was the second. Yes, I just selected the first one.
Okay, we are 90% confidence that the true mean heart rate is between 45 and 105.
Yes, let's accept.
Okay, so let me see what I've got here that shows up that's not right. Question 12, there is not enough data. So that goes back to, which question was that? That's going to be two, three, 4, 5, 6, 7, 8, 10. So that's 10. So that's question 9 on the homework assignment. And then let me see what else I'm missing here. I missed question 15.
Question 15?
The nicotine one. I chose reject.
Oh, you probably did the reject the HA.
I did.
The alternative.
Okay. Reject the null. Reject the null. Right. Okay. So that's where I messed up. So I need to go back here and okay, so let's see here. So 12. Let's talk about that. The group statistics wants to determine if students in some apartment building. So that's the one where we need to find out where the data appears to be bell-shaped with no outliers, nearly equal. Can they use an ANOVA hypothesis test for this question?
That one, as I was getting the one that was mentioning that we were missing the variances, I think was the other option.
Mm-hmm.
Yeah.
I was thinking of that one initially, but because it's talking specific, because yes, we got some information, but not all of the information, specifically that part.
So what do you think the answer truly is then? See, the reason that the ANOVA one, it talked about them being right skewed and not bell-shaped. But I don't remember the reason why from the reading.
That one is the F statistic. The F statistic is the one which is right skewed.
Okay.
And never will be negative. That is here. Just let me find it. Yes, the F statistic is right skewed, never negative, and the p-value is the area and the right tail. And it says we will never divide the area and the tail.
So does that mean that you think that it's enough that the data is approximately bell-shaped?
Well, I guess it's a group of students want to determine if students in some apartment buildings get better grades than the students in other apartment buildings. They collect GPAs from an anonymous random sample of size 15 from each of the 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers and the same variances are nearly equal. Can they use an ANOVA hypothesis test? Well, we can take as well because it says the data for each apartment building are bell-shaped with no outliers and the sample variances are nearly equal. Even though those are not being stated, it is telling us that variances are nearly equal and as well that it is bell-shaped. I would say it is enough that the data for each apartment building are bell-shaped with no outliers and the sample variances are nearly equal, which actually are the 2 requirements.
Right. Yeah, I didn't see that before where it talked about that in the.
Okay.
So yeah, I think it is that. Yes, it is enough.
Yes, because what I think we focused on was to check the values itself, but it is just mentioning that we have that information.
Yeah.
I would go with that one.
Okay.
So then just let me re-enter all the other questions.
Just going back and making sure I got them.
Yes, that's what I'm doing as well. Negative 43.23.
All right, let me go ahead and try this again and see what happens here.
Okay, just a minute, and it was giving me everything right.
Nice.
What's that?
Just submitted, and I got 12 correct.
Okay, good. Good,
You guys are fast.
SMA. We decided to try yes, there's enough data.
Correct.
Okay. Got a type 1 error. Margin of error 2. 0, 2, 5. Down 4.168. 5. 217.
All right, I just submitted.
Okay, I'm almost there. Just hope my notes are correct here.
No, that's how I was. I wrote everything right.
Negative 423. 5. .002. Okay, 21. And all right, see what it tells me when it comes through. I must have missed something somewhere because I'm not perfect, but I'm close enough. So,
Oh, no.
all right, I missed a half point on one of the questions on the lower bound. I must not have had them. That's all right. Must have wrote something down wrong again.
Wow.
Aha, I see what I did wrong. That's all right. Well, good talking, guys.
Yeah.
I appreciate all your hard work and patience with me tonight. Like I said, as soon as we're off here, I'm gonna close everything down and restart my computer, and hopefully it will.
Yeah, hopefully
That's certainly. Okay, so good luck on the test.
Have a good weekend, and we'll talk to you later.
Yep. Good luck, everybody.
Bye-bye.